All right, welcome geometry students. In this video, we are going to take a look at some angle pair relationships or angle relationships that we have in polygons. We are going to start with this warm-up. This goes back to what we did at the beginning of chapter 8. This shape is a dodecagon, which has 12 sides. I want you to go ahead and use the formula for the sum of the interior angles to go ahead and solve for the sum of the interior angles of this particular polygon. Go ahead, take a minute, pause the video, and put in your answer when you have it. All right, so as I work that through, I'm going to go ahead and put in a 12 for my number of sides. And then 12 minus 2 is 10 times 180. There are 1,800 degrees in the sum of this interior angles. Today we're going to focus on this interior angle here, but we're also going to be looking at the exterior angle as well. And then we're going to be focusing on regular polygons, which is a little different than the polygons we've been working with. Let's jump in. All right, so it says in lesson 812, you discovered how to determine the sum of the interior angles of a polygon with any number of sides. What more can you learn about a polygon? Today we're going to focus on interior angles and exterior angles of regular polygons. Remembering that regular polygons means that we have equal sides and equal angles. As you work today, keep the following focus questions in mind. Does it matter if the polygon is regular? Is there another way to find the answer? And what's the connection? So we'll get started on this first one here. It says, determine the measure of each interior angle of a regular octagon. Explain how you found your answer. Well, an octagon is 8 sides. So before I find each angle, and again, I know it's a regular octagon, which is helpful because I know that they're all the same. But before I find each angle, I have to find the sum of the interior angles. So I'm going to use my n minus 2 times 180 formula. And I'm going to go ahead and put in an 8 for the number of sides. That leaves me with 6 times 180, which is 1,080 degrees total for all 8 of these interior angles. Now, because I know it's regular, that means all the angles are the same. So I have equal angles. So I'm going to take this 1,080 degrees and divide it by the 8 angles that there are to get my measure of each individual angle. So I know each individual angle here would be 135 degrees. Again, I can do that because it's regular and all the angles and all the sides are the same. Okay, what about interior angles of other regular polygons? Find the interior angles of a regular nonagon. And that's 9 sides. Whoops. And a regular 100gon, that's 100 sides. Okay, so step 1 as we work through this is first to find the sum and then to find each angle. So to find the sum, I'm going to plug into my n minus 2 times 180 formula, and then I'm going to plug in 9 minus 2. And then when I multiply that out, I'm going to get 1,260 degrees. That's the sum. Now I'm talking about a regular nonagon, so if I want one angle, I'm going to divide that by the 9 different angles that there are. So one interior angle is going to be 1,260 divided by 9, or 140 degrees. I want you to do the same thing for 100 sides. Go ahead and put in what the sum is, and then find one interior angle. All right, so the sum is going to be 98 times 180 degrees, or 17,640 degrees total. And then the measure of one angle is going to be that divided by 100. One interior angle would be 176.4 degrees. All right, let's look at our next problem here. It says, Vern states, if a triangle is equilateral, then all angles have equal measure and must be a regular polygon. Does this reasoning work for polygons with more than 3 sides? Investigate the idea below. If all sides of a polygon, such as a quadrilateral, meaning 4 sides. If all sides are equal, does that mean the angles must be equal? If you can draw a counterexample. So go ahead and take a minute and give me your opinion here, or your thoughts here. If all sides of a polygon are equal, do the angles have to be equal? Okay. No, the angles do not have to be equal. A counterexample here would be a rhombus. The sides are equal, but the angles are not. Part B, what if the angles are equal? Does that force the polygon to be equilateral? Okay, so again, if I have a 4-sided shape and I have equal angles, do the sides have to be equal? The answer to that question is no, because I could draw a rectangle as a counterexample where I have 4 equal angles, but no equal sides. So triangles are special in that if they have equal sides, they also have to have equal angles. If they have equal angles, I know they also have equal sides. Triangles are the only polygon where if I know the angles are equal, the sides are also equal, and vice versa. All right, let's take a minute and talk about exterior angles. I have a couple different shapes here for you, and we are going to use them as examples. So this first one here is a regular pentagon. I have 5 sides here. My exterior angles can be formed by extending the sides in all directions here. Okay, so the angles that I formed here are exterior angles. Now I know that each interior angle here would be the same. So if it's a pentagon, I know that each interior angle would be 5 minus 2 is 180. So this is going to be the total. I know the total is 540 degrees, and I'm going to divide that by 5 to find out what each angle is. I know that that's going to be 108. So that I know that each of these exterior angles would be 72 degrees because this has to make a straight angle pair. And if I have 5 angles that are each 72 degrees, in this case they add up to 360. These are my exterior angles. Okay, let's look at another shape. This is a regular hexagon. So again, to find each interior angle, I would do n minus 2 times 180. And then I'm going to divide that by the number of sides that there are. So I'm going to go 6 minus 2 times 180. And I'm going to divide that by 6. 6 minus 2 times 180 is going to go ahead and give me 4 times 180 or 720. So 720 degrees is my total. Divide that by 6, and I know each of these angles is 120. Okay, but then when I draw my exterior angles here, again, I'm just going to extend the sides going in one direction around. I know that these angles all have to be 60 because they have to add up to 180 because they make a straight angle pair. So I'm going to take 6 times those 60-degree angles. If I count them, I have 6 of them. And again, I get that exterior angle sum of 360 degrees. Okay. Now I have a regular octagon. I can go ahead and do the same thing. Do the n minus 2 times 180 to figure out how many degrees there are total. Divide by 8 to find out what each one is. And then figure out what each exterior angle is. Again, when I look at 8 times the 45-degree exterior angle, I'm going to get 360 degrees. And then lastly, this shape here has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sides. This is a decagon. And the decagon has total interior, some of the interior angles. Again, I can do by the n minus 2 times 180. This should be a little repetitive for you by now. And now I'm going to go ahead and look at my exterior angles. Once I know what each interior angle is, I can do 180 minus that to find the exterior angle and then count up and check out the sum of those.